Welcome back to Discovering Geometry with Mrs. Berry. This is Lesson 40. Today we will be studying circles, specifically the circumference to diameter ratio, which will be pi. This is a fun lesson where we will investigate the relationship between the diameter and the circumference. Remember, the measure around the edge of a polygon is called the perimeter, but the measure around the edge of a circle is called the circumference. Here in red, we see a square. The perimeter would be measuring all four sides. The yellow circle, the circumference would be measuring from one point all the way around the edge back to that point again. If you have a tennis ball can, a can that holds 3 balls, you should get it out and try this experiment. What do you think is larger, the height of the can or the circumference of the can? Well, what is the height equal to? It would be the 3 tennis balls' diameters put together, because the 3 tennis balls sit on top of each other in the can. How does the circumference, the distance around the can, relate to the height? You could use a string to measure around the can and then pull that same string out to measure the height in comparison. Are you surprised by the results? Do you think around the can will be smaller or larger than the height? If you don't have a can to try this experiment, let's keep going and see if you can figure out what the answer would have been. So our investigation today is going to be needing 3 or more round objects, 3 or 4, a ruler or tape measure, and then thread or some kind of thin string to help you measure things. We're going to measure the circumference of each object. Use the thread or the string as necessary to go around the object and then pull it straight against your tape measure or ruler. Measure the diameter of each object. Remember, be as precise as possible in these measurements. You want to go down to the smallest marking on your ruler, and even sometimes you can estimate between the smallest marking to get a very accurate number. Divide the circumference by the diameter and record your answers. Compare this ratio of circumference divided by diameter for each object. At the end, average all your ratios and see what it is. So here is our chart that we will record our data on. Here's a picture of the diameter of the plate. So I measured the diameter just with a ruler. I chose to use centimeters, and then my ruler also had markings for millimeters. I then used a string to go around the edge of the plate. In the picture, you don't see it tight, but I taped one end, and then I measured it tightly across. Yarn is a little bit difficult to use because it will stretch. So I suggest a type of string that would not be stretchy. I then put that string out on my yardstick or my meter stick and measured it down to the 1/10 of a centimeter. So my plate measured 66.8 centimeters in circumference and 21.2 centimeters in diameter. That C to D ratio was then 3.15. Next, I measured a peanut can lid at 20.5 centimeters for circumference and 6.6 centimeters for diameter. That ratio was 3.11. Make sure you use at least 3 or 4 objects, more if you would like, and then average your ratios. My average came out to 3.13. If you know anything about the number pi, you can see that that should be really close to pi, which is 3.14159, etc. So we define pi, which is this symbol here, as the ratio of circumference to diameter. If you solve the formula for circumference, you would get a formula for the circumference based on the diameter. So let's look at that right now. If pi is equal to C over D, and we want to solve for C, then we're going to multiply by D on both sides. That would cancel it out over here, and we would have that the circumference is equal to pi D or D pi. If you were to replace the diameter with 2 radii, meaning the diameter is equal to 2r, then you would get a formula for circumference of the circle based on the radius. So our conjecture is that if C is the circumference and D is the diameter of a circle, then there is such a number pi so that C equals pi D. If D equals 2r, where r is the radius, then what does C equal? You should be saying 2r pi. The order in which we list these is not important because multiplication is commutative, meaning we can multiply them in any order. A lot of times you'll see this formula as 2 pi r. For our work in this class, use the pi button on your calculator if you have one, or the estimate of 3.14 when you're making calculations. If you're ever asked for an exact answer instead of an approximation, then you should leave your answer in terms of pi. Let's use some examples and see what I mean. Example 1. If a circle has a diameter of 3 meters, what is the circumference? We can use a calculator and round our answer to the nearest tenth of a meter. So we start off with knowing that the diameter, or D, is equal to 3.0 meters. What is our formula for circumference? It's pi times D. If we plug in D as 3, that would be 3 pi. I just switched the order right here, but D was 3, or 3.0, times pi. But they asked us to go ahead and round to the nearest tenth. If we were asked for an exact answer, it would be 3 pi meters. But since we are rounding, we're going to use a calculator. And I just put in 3.14 for pi. So that answer comes to 9.42. And they asked us to round to the nearest tenth. So you want to round to this place, which means that the 2 will keep us at 9.4. And then we always want to make sure that we use our units if they were given. So 9.4 meters. Let's look at another example. If a circle has a circumference of 12 pi feet, what is the radius? So here we are given that the circumference is 12 pi feet. And what was our formula for circumference? It was D times pi, or pi times D. Setting D times pi equal to 12 times pi, hopefully you can see, we can actually divide by pi because pi is just a number. And then that gets us to D is equal to 12. If you saw that without dividing by pi, that's fine also. 12, and then because circumference was 12 pi feet, then our diameter is 12 feet. Make sure you label the units. Our last example, if the distance from the center of the Ferris wheel to one of the seats is approximately 90 feet, what is the distance traveled by a seated person to the nearest foot when they go around the Ferris wheel one time? So going around the Ferris wheel is going to be our circumference. We are given that the center to the seat is 90 feet. Is that our diameter or our radius? It's our radius. So our radius is 90 feet. And we want to know what is the circumference. So we need to use our formula for circumference that involves the radius. That would be 2 pi r. If we want to know it to the nearest foot, that means that we're going to use our estimation of 3.14 for pi. Or again, if you have a pi button on your calculator, you can use that. So 2 times 3.14 times my r, which is 90, is what the circumference is. When I plug all those numbers in, I get 565.2. I'm rounding to the nearest foot, so I don't need to use my tenth. That 0.2 will make this round even to 565. And my units would be in feet. So that is the distance of one revolution. Now we're getting back to a little bit of algebra with our geometry, but we still have to think about shapes and how they relate to each other. I hope you enjoyed this lesson.